So the next example is going to be a little complicated. From time to time, we may have to actually find the definite integral, the area, in conjunction with using the u-substitution rule. So things are going to get a little more complicated. So let me actually kind of do that here. So I like to integrate 3x over x squared plus 1 from -3 to -1. Now the first thing you notice is that 3x over x squared plus 1, this is not a simple function. So I'm going to have to use the u-substitution rule to deal with this derivative. So let's see, I'm going to let my u be the troublesome part, which is going to be the my denominator there, which is going to be x squared plus 1, so that my du is just 2x dx. So the terms are slightly different, but it differs only by a constant, so this is okay. Now then, so I knew that this is going to be just the integral of, let me see, if I do the substitution, I'm going to get, well, let me see, my dx, is going to be du over 2x. So when I substitute things back, my dx, I'm going to get a constant 3/2 here. So my whole thing is going to be just the integral of 3/2 of 1 over u du. Because my x squared plus 1, that is my u, and my dx is du over 2x, so the x kind of get cancelled out, but I still have the constant 3/2 left over. Now, there are two ways to deal with this. But before I get into that, let me actually show you first the wrong way to do this. The wrong way to do this, because now things get a little complicated because there are numbers -3 and -1 here that get involved. So the wrong way to do this is to, well, I do the u sub and I get 3/2 1 over u du. So let's integrate this whole thing from -3 to -1 of 3/2 1 over u du. So the integral of 1 over u is going to be log of u, and it goes from -3 to -1. So I get 3/2 log of absolute -1, which is log of 1, minus 3/2 log of 3. So once again, this is the wrong way of doing that, and that's because this -3 and -1, this is the value of x. But when you change your variable to u, then u is no longer going from -3 to -1. So you need to somehow make the corresponding change. And I said there are two ways to do this. So let me show you the two ways. First thing, you can think that, well, my u is x squared plus 1. So if my x go from -3 to -1, what is the value of u then? So when my x is -3, my u is -3 squared plus 1, which is a 10. And when my x is -1, then my u is 2. And you can kind of mentally check that when x runs from -3 to -1, x squared plus 1, which is u, actually run from 10 to 2. So that makes sense? So when I have this integral, that means I'm going to have integral of 3/2 1 over u du. But instead of running from -3 to -1, -3 to -1, that are value of x. But it corresponds to the value 10 and 2 of u. So I actually have to make that change. Now then, I can take the integral. I can integrate. So that's going to be, let me see, 3/2 log of u, which goes from 10 to 2. So notice how 10 is bigger than 2, but that's okay. I'm still going to go by the rule. So that's going to be 3/2 log of 2 minus 3/2 log of 10. So that's going to be my answer here. So that's one way of doing it. Let me also show you an alternative way of doing the same thing. So I'm gonna, I have, so this, I'm gonna just go ahead and integrate then. My 3/2 of 1 over u, that's gonna be the same as, well, if I integrate the guy, that's gonna be 3/2 of log of u. It goes from somewhere to somewhere. Now, it goes from, I see that it goes from -3 to -1, but that's the value of x. So I'm just going to say that it goes from when x equal to -3 to x equal to -1. So instead of computing what is the value of u, I'm going to leave the x as is. And I'm going to substitute the x back later. So let me actually go ahead and I knew that u is x squared plus 1. Now that I have already took the integral, I can substitute things back. So this is log of x squared plus 1, where x goes from -3 to -1. And now things make a lot more sense because this is the value of x, and I'm seeing x in here. So now I can actually substitute -3 and -1 into my equation thingy. And it is going to give me 3/2 log of -1 squared plus 1, which is going to be 2 minus 3/2 log of -3 squared plus 1, which is going to be 10. And it's actually quite straightforward to check that these two guys are the same thing. So when you have to compute the definite integral, where the u-substitution is involved, make sure that you actually do something about the endpoint value because it doesn't go in as is, because that's the value of x, not the value of u. There are two ways to do that. You can change the endpoint so that it corresponds to u, like what I did in the first case here. Or you can actually integrate in terms of u, but substitute x back in so that you can plug in the value of x. They are, these two methods is actually equivalent. So if you know one, you should know how to do the other, but just make sure that you don't go in with the incorrect way.